Thank you, Kenneth. Okay, so I'm recording the session. Again, when we do 2 to the k design, usually it becomes very demanding once we have multiple factors k, no? The larger the number of factors, the greater the number of experimental runs we need to do. So in that regard, we need to reduce it without sacrificing the integrity of the experiment, no? And the way we do that is to employ what we call as the sparsity of effects principle. Okay, so the sparsity of effects principle states that a system is only usually dominated by the main effects and lower order interactions lang. So parang the most likely na magka-cause ng contribution dun sa or the most likely na magkakaroon ng significant effect dun sa response natin is either the main effect, yung single factor lang, or pwedeng yung mga two-factor interactions at most, no? Usually pag magkaroon tayo ng or pagka in-involve na natin yung mga three-factor interactions, four-factor interactions, etc., yung five-way and higher, three-way and higher, I mean, usually hindi na sila nagiging significant effect, no? So this is what we call as the sparsity of effects principles, and because of this, uh, parang kaya natin ma-reduce yung experimental runs natin uh, through blocking, no? So this is different from the blocking that we did sa RCBD, no, or the randomized complete block design. Itong blocking na to, this is blocking the experimental runs into a certain in a certain way that that takes advantage of this sparsity of effects principle. Okay? So a 2 to the k or a fractional factorial design is usually expressed as a in this notation, no, 2 to the k minus p, where this p here is the number of blocks that the design is being reduced to, or more accurately, this is 2 to the p, yung number of blocks that you are reducing your design to. So for example, if you have 2 to the 5 minus 2, kunwari, 2 to the 5 minus 2 means that you have 5 factors, pero you are reducing it by 2 to the 2. Okay? So 2 to the 2 is 4. So magiging i-reduce nyo siya by 4 blocks. Okay? So, or i-reduce nyo siya into 1/4 of the original size of the design. Okay? So P here actually is yung ano natin, no, the number of design generators or defining contrast na kailangan para gawa natin yung pag-reduce ng design natin. Okay? So let's consider a situation in which we have three factors, each at 2 levels. So we have 2 to the 3. And we can't afford to run all of those 8 combinations, no? So, pero we can run half of that experiment. Kunwari lang kaya natin, hindi natin kaya yung 8, pero kaya natin half of the 2 to the 3 design. So we need to determine kung alin yung relevant sa atin na treatment combinations. Okay? And here we will use yung mga tinatawag natin design generators, no? So, first, identify natin yung number of blocks. So if we are to reduce it by 2 or into 2 halves, so meron tayong 2 blocks, tapos pipili tayo ng isang block na yon. Therefore, we are actually doing a 2 to the 3 minus 1 experiment. No? So 3 again. Nag-start tayo with 2 to the 3. Tapos, i-reduce natin by 2 to the 1, which is ito. So, kaya siya magiging 3 minus 1. So, that essentially means 2 to the 3 divided by 2 blocks. Okay? So, the higher the denominator is, the lesser will be the information obtained from the study. And minsan, we should be careful on how we do fractional factorial designs. Pero meron namang mga guides, no, on how to do this, or meron mga standards on how to do fractional factorial design. Okay? So, again, yung defining contrast, ito yung kailangan natin para makapag decide tayo which treatment combinations belongs to which block. Okay? So, if we have one defining contrast, or if we have 2 blocks, then we are required 1 defining contrast. Tapos kung meron tayong 4 blocks, we are required 2. 8 requires 3. So essentially, siya yung, again, yung P dito, no? So for example, atong sa example natin dito, 2 to the 3 minus 1, we need 1 defining contrast to produce 2 to the 1 block. So kung if you have yung sinabi ko kanina 2 to the 5 minus 2 na type of fractional design, then ang kailangan natin to produce the 2 to the 2 blocks, which is 4 blocks, we need 2 defining contrast. Okay? So kung ano yung number dito, ano yung P dun sa 2 to the K minus P, siya yung number of defining contrast, and 2 to the P will be the number of blocks that will be available for us. Okay? So, meron tayong ano no, um, mga standard tables to select the defining contrast, and the defining contrast will look something like this, no. So for example, this is a standard table and this is taken from Montgomery, no. Pero meron din siya, you can search it all around the internet, no. Para mahanap niyo yung mga design generators na to. So ang keywords na i-search nyo is design generators, fractional factorial design. Pwede rin defining contrast. Pero usually mas lumalabas siya pag design generators yung in-input nyo. Okay? So, for example, if you have three number of factors, tapos you are reducing it to half of the size, so that's 2 to the 3 minus 1. We have one defining contrast, which results into 4 runs na lang. No? So, from 2 to the 3, magiging divided by 2 gives us 4 runs. And the design generator for this particular case is C equals plus minus AB. Okay, so itong design generators, I'll show you exactly how to use this, no? Pero essentially from the design generators, kaya natin ma-produce yung defining contrast natin. Okay? Tapos dito, pagka meron tayong, let's take another example, no? Kunwari, number of factors, we have 6 number of factors, then we can choose either 2 to the 6 minus 1, this is reducing it by half, or 2 to the 6 minus 2, which is 1/4. Tapos ito 2 to the 6 minus 3, which is 1/8 of the design. No? Okay, 2 to the 6 2 to the 6, or if you take the full factorial design, is 64. So reducing it by halves gives us 32. Reducing it by 1/4 gives us 16. Reducing it by 1/8 gives us 8. Tapos again, sabi natin kung ano yung number dito, yung 2 to the K minus P, yung P will be the defining contrast, which is also our design generator. No? Okay, so we have this is 1. So magiging 1 design generator siya. Ito F is equal to plus minus A, B, C, D, E. Pag 2 siya, that means na 2 yung design generators. So that's E equals plus minus A, B, C, and F equals plus minus B, C, D. Tapos yung last is pag 3, kailangan 3 din yung design generators natin, which is plus minus AB, plus minus AC, and plus minus BC. And you can go larger values. No, ito, this is at 2 to the 7 design. You can reduce it by 7 minus 1, 7 minus 2, 7 minus 3, or 7 minus 4. Tapos meron silang parang kasamang design generators for those types of designs. Okay? So let's try to I don't know, determine how we can use these blocks. We'll be using Excel. Yung first step is or yung next step is kailangan natin i-compute yung assignment values, no, known as L. Pero itong L na to, this is usually in terms of zeros and ones, no? Pero the method I'll be teaching you hindi na actually mag-involve ng L, or iba yung approach niya, kumbaga. So hindi mo tayo magfo-focus dito sa L values, no? Pero essentially this is just saying na kung ano yung from the design generator, ano yung pipiliin natin na, or ano yung combination of the design generators na gagawin natin para ma-produce yung blocks. Okay? So kaya siya may ganito, L, L1, L2, L3, L4. L1, L2, L3, parang ganyan. So it will make more sense, no, pag pinakita ko yung Excel. Pero essentially parang sinasabi niya is kunwari itong design, itong 2 to the 3 minus 1. Para makuha mo yung block 1, kailangan iset mo si C equal to plus AB. So that is block 1. Lahat ng conditions or treatment combinations where C is positive AB, yun yung ano natin, block 1. Tapos doon sa kabilang block naman, that is the case wherein C is equal to minus AB naman. Okay? So ganun siya binablock, no? So if you have two design generators, that gives us 4 possible ways, no? So pwedeng D is equal to plus AB, E is equal to plus AC. So that is block 1. Block 2 could be D is equal to plus AB while E is equal to negative AC. That is block 2. Tapos yung block 3 naman natin could be D is equal to negative AB, DE is equal to positive AC. That's block 3. And lastly, yung block 4 natin is both negative C. D is equal to negative AB while E is equal to negative AC. Okay? So, yan yung role ng design generators, no, to determine the blocks. Sila yung magde-determine kung alin yung treatment combinations na kukunin natin for the different blocks. Okay? So dito, it works much the same way dito sa yung L method, no? Pero medyo confusing for me, no? Confusing kasi yung L method, so hindi ko na ituturo to. Pero basically parang ganoon lang siya. So kunwari, yung design generators L, ang L mo ang mangyayari is meron kang L is equal to 0 and L is equal to 1. So from when there is a case that L equals 0, yun yung block 1, L equals 1, yun yung magiging block 2. Tapos dito naman, pag 4 blocks, so magiging L1 is equal to 0, L2 is equal to 0, tapos L1 is equal to 1, L2 is equal to 0, tapos third block is L1 is equal to 0, L2 is equal to 1, and last block is both equal to 1 sila. So parang ganoon. So similar dun sa ano, no? So pipili tayo sa design generators, pipili lang tayo ng plus minus. Kung plus AB ba siya or minus A AC. Parang ganoon. Kung if you are choosing this one. Okay? Okay, so so parang ganito, okay. This is what I was referring to earlier, no, yung assignment values using yung pagka nag-L method tayo. Pero again, yung ipapakita kong method sa inyo hindi na gagamit nito, no. We will be sticking with the design generators lang. Okay? Then after that, pwede na tayo mag-select any of the blocks because we have what we call as kumbaga may mga aliases tayo or nagko-confound tayo. And later I'll show you na kung ano yung different factors na actually that are being confounded, no? Pero what confounding essentially means is um, we are saying na hindi natin ma-distinguish kung ang effect ba ay caused by a main factor or a two-way factor. So kunwari if we have an alias of uh, kunwari, ang alias natin is A is equal to, random lang to, no? A is equal to BCD, kunwari, ganyan. So when we did the aliasing, we determined na A is equal to BCD. So we are saying na confounded yung effect ni BCD with the main factor A. So technically, hindi natin alam kung dahil ba to or yung yung effect ba doon sa response is due to main factor A or due ba siya to the three-way interaction BCD. Pero based on sparsity of effects principle, parang pwede natin masabi na parang hindi siya dahil sa BCD kundi dahil sa A siya. So kaya nagwo-work yung yung ganun, no. So pero technically dapat kumbaga if you report it, parang you report it as a kumbaga confounded yung parang um, SS na yon, yung makukuha nating sum of squares, no. Okay? So I'll be showing you an example para mas malinaw, no. Okay. So copyin ko lang tong ito, spaces. Okay, let's start with this one, no? So, kunwari lang, we're trying to do the simplest one, 2 to the 3 minus 1, kunwari tayo. 2 to the 3 minus 1, so that's 3 minus 1 is 2 to the 2, which gives us 4 runs, no? And we have a design generator of C is equal to AB. Okay? So, let me zoom that in. So, first step is, lagay lang tayo ng ano, no? Yung first block natin, which is C is equal to plus AB tayo dito. Okay? Tapos we have AB, AC, and BC. Tama? So, kumbaga, ibubuin lang natin yung parang table of signs natin dito. Okay? So, we have A, B, C, AB, AC, BC, tsaka ABC. Okay? So, ang difference lang is, di ba, nung nag-table of signs tayo sa full, C lang to. Pero this time, since meron tayong design generator, i-note natin na C here is equal to plus AB. Okay? Tapos, this will be, meron tayong 4 runs dito, no? So, 1, 2, 3, 4. So, pwede tayong gumawa ng isa pang table. And this will be our next block, no? And this block will be the negative AB na block. Okay? So, we have AB, AC, BC, and BC, and ABC. Okay? So, first, ang kailangan natin is yung, ano muna, no? Kailangan natin yung defining contrast. So, the way we do defining contrast is, before I proceed with that, no, kailangan, I'm sorry, class. So, kailangan natin i-take note na when we are, we can actually, di ba, from the design, from the table of signs that we did yung 2 weeks ago, no? Parang we were actually multiplying columns, no? So, for example, if we multiplied columns, we will get, kunwari, A times B gives us AB. So, kung negative to, kunwari, negative 1 to, negative 1 din to, this gives us AB should be positive 1. Parang ganyan, no? So, we'll do something like that, no? When we are using yung factorial designs, if we multiply columns, we are actually just multiplying the values, no? And if we multiply, kunwari, if we multiply A by A, this gives us a value of 1, no? Or sometimes known as an identity. Tapos yung identity natin has the value of 1. So it makes sense, no? Kasi kunwari, negative 1 si A multiplied by negative 1 again gives us just positive 1. Tama? So parang 1 square lang siya. So anytime A is multiplied or anytime we try to get or kung lalabas yung value or yung column twice, that just gives us the identity which is just 1. Okay? So ang defining contrast kasi is the defining contrast is given as the identity is equal to a certain parang value, no? Parang ganun. Yan yung defining contrast. So if you want to get the defining contrast, then we can do it in 2 methods, no? Itong kunwari, we are doing 2 to the 3 minus 1. So that's C is equal to plus minus AB. So what we can do is, para makuha yung I, we just multiply both sides by C. Tama? So if we do C times C is equal to AB, that's plus minus AB, no? Times C. So we multiply C on both sides. And therefore, itong left side becomes I, and the right side becomes ABC. So our defining contrast here is I is equal to ABC. Okay, nakuha ba yan? So that's I equals ABC. So another method is we just square the the design generator. So pwedeng instead of doing I is equal to ABC, pwede ring C is equal to we square the design generator, and design generator natin is AB. So multiply it by AB is equal to AB times AB. And both methods will work, no? If you do something like this becomes ABC is equal to I. Tama? Because, and let me expand, magiging ano to kasi, AA, BB. And AA is 1, BB is 1, so ABC is equal to I. And this is again the same defining contrast dito, no? So you can use either method, and this is important because we will use this defining contrast to determine the aliasing, no? Okay, which I'll be showing later, no? But right now, lagay lang natin dito, defining contrast natin is I is equal to ABC. Okay? So now, gagawin natin is we do ganito. So parang we start off with, dapat alternate muna. 1. Ganyan. And we do negative 1, negative 1, negative 1, 1, and 1. Okay, so ito alternating every row. Ito alternating every 2 rows. So once na-determine na natin to, pwede natin makuha yung C equals AB. Okay? So C equals AB is just equal to ito times AB. So, positive kasi siya. So, pwede natin makuha siya. Ganyan siya. Okay? So, that's C equals AB. Tama ba? Okay. Tapos, sorry. Wala na pala tong, wait lang class. Okay lang pala. Okay. So, ito, C equals AB. So, okay na yan. Tapos, AB is just equal to ito times ito. In this case, same lang si C at AB, no? And that's okay. Same lang sila kasi ngayon, naka-positive AB kasi siya. Okay? So, yan. Tapos, C equals, ito AC naman. Ito, AC. Multiply lang natin. Next, equal BC naman. B times C. And last is ABC, which is A times B times C. Okay? Ganyan. Okay? Now, let's do yung dito sa bottom, which is equal to, we can copy this, no? Yan. Tapos C ngayon is equal to negative AB. So what we do is negative of A times B. Okay? And we can drop this down. Tapos pwedeng copyan lang natin to, no? Ganyan. And the values will change because yung AB natin, naka-dynamic naman to na referencing, no? So notice na ito, B A times C to. So biglang nagbago naman yung ano natin. Okay? Now, to determine the parang treatment combinations, we just do the method we did 2 weeks ago, no? Yung parang titingnan lang natin kung ano yung positive doon sa main factors at kung ano yung positive, siya yung lalabas na number, kumbaga. So, pwede tayo mag-if function actually, no? So, para pwede tayo mag-concatenate. Tapos, if, ano ko lang, no? Hindi ko kasi kita. So, pwede tayong concatenate if eto is positive, greater than 0. Then we type in A. Tapos kung ifs pala gagawin natin. Ifs. Di okay. If lang pala. I-type in A. If if not greater than 0 siya, then we just type in a blank. Tapos, copy natin ulit ito. Pwede ganito yung gawin nyo or pwede ring manual naman gawin nyo class, no? Kung short, kung konti lang yung number of parang combinations, then pwede naman i-manual nyo na lang. Ito, gusto ko lang ginagawa to kasi mas, lalo na pag masyadong madami na yung treatment combinations. So, something like, kunwari 2 to the 6, masyadong madami na yung factors na tinitingnan, no? Tapos, it gets a little bit confusing, no? So, I just like to do this. So, ito magiging C2 na siya. So, titingnan natin if itong column ba na to and gagawin natin B to. And last na ano natin, concatenate na argument is ito. Gagawin natin D. Tapos ito naman is C. Tapos we close the concatenate function. Again, concatenate is just combining strings, no? And our strings is ito yung first string natin, which is an if statement. Lalagay tayo ng A or blank. Tapos ito naman yung second na concatenate natin is lalagyan natin siya ng B or blank. Tapos itong last is lalagyan ng C or blank. Okay? So if we do that, we get ganyan. Ito, pwede natin i-drag down and we can see na meron siya dyan. And pwede actually natin i-drag down pa siya pababa. And ito, patanggalin na natin. And this is blank lang siya kasi ito yung naka-negative lahat, no? Actually, pwede natin palitan to. Gawin natin siyang ganyan, no? Kasi ito yung notation natin for when all main factors are in their low setting, no, or yung -1 na setting. Okay? So ito siya. We have generated the two blocks. So ito yung two blocks natin. So we can choose either block because when we do the experiment, pwedeng ang gawin natin is this block or pwede rin ang gawin natin is this block. Wouldn't really matter no, kung anong pipiliin natin. If you do that, if you were to compute the aliases, ang gagawin natin is we just multiply the defining contrast by the main na factors. No? So for example, A multiplied by the defining contrast ABC gives us this gives us AABC. Tama? And AABC is equal to sorry. To get A, parang ganyan. So, sige, I'll take it one more step. No? So, para kasi ang ginawa natin is A is equal to A times I. So, this should give us, since I is equal to 1, then therefore, A is just equal to this A right here. Tama? So, kaya siya naging ganyan. So, pwede ko siguro igawin siyang isang line lang, no? Para mas malinaw. A is equal to A times ABC, therefore equal to sa AA BC. So if we simplify this, we get A is equal to BC. Ito yung tinatawag nating confounding, no? So kumbaga the A is confounded with the effects of BC. Okay? So kaya same lang tong A na to, itong A na to, itong A na to na treatment combination is just the same as if we did this treatment combination, yung BC. Parang ganun yung effect. Kaya we can choose either one. And let's do it for B naman. B is equal to, hindi ko na ipapakita yung ano, no? Pero here, B should be equal to, if we multiply it by ABC, then we get AC. Tapos C is equal to multiply by ABC, we get AB. Okay? So ito yung confounding. So once we have the ANOVA table, kunwari, ganyan, usually, what we do is, pagka inano natin yung, di ba, ang ano natin is source, SS, DF, MS, etc. Pagka ginawa natin tong ANOVA table na to, usually we write it as, di ba, yung usual way natin is A, B, C, tapos yung A, B, A, C, ganyan, ganyan. Okay? So, dito sa pag-fractional factorial design, what we do is we do something like A plus BC. So, parang sinasabi natin na yung combination nung yung combined na effect ni factor A and factor BC is yung sum of squares niya is this one, is whatever value you get here. Okay? So parang sinasabi natin, hindi natin sure kung galing ba siya sa BC or galing siya sa A. Pero again, dahil sa sparsity of effects principle, parang sinasabi natin na negligible to and most likely caused by A siya. Okay? So you can write it as just A, no? Pero for accuracy, kasi the purists would say na hindi siya technically A, parang technically it's A plus BC. Okay? So A plus BC, tapos eto B plus AC, and lastly C plus AB. Tapos, ABC is not confounded with any other interaction. So, pwedeng ABC. Meron siyang sariling ano. Okay? Parang ganun siya sa ano. Ganito natin ginagawa siya. So, parang yung formula it will be the same as yung fractional factorial, no? So, since you already made the table of signs, so I'm suggesting na gamitin nyo is table of signs method. And in fact, hindi nyo magagamit yung Yates technique, no? Because Yates technique requires standard order and hindi naman to naka-standard order. So, table of signs yung gagamitin nating method dito. We have the table of signs. Tapos, if we have the yield dito, then we can compute for the corresponding na contrast niya. Di ba? May makukompute tayong contrast dito. And from that contrast, pwede tayo mag-compute ng SS. And if you want, you can also compute for the effects, no? So, meron tayong yung effect. Tapos SS. So, parang ganyan. You can compute it. And Effect is just equal sa etong contrast, ito yung nagsasum product tayo from last from 2 weeks ago na discussion. Tapos yung effect is just 2 times yung contrast divided by the number of observations. Tapos yung sum of squares is contrast squared divided by number of observations. If I remember the formula correctly. Okay? And actually, ito yung magiging quiz nyo, no, or homework nyo. What I want you to do is you take yung previous natin na example. Wait lang Let me try to find it. But I'll be posting it. I'll be adding it either way, no, doon sa offline natin. Saan ba yun? Ito. So we start with something simple lang muna, no? And ito yung ginawa natin last meeting. So ang gagawin lang natin is i-reduce nyo lang. So from 2 to the 3 design, gawin nyo siyang 2 to the 3 minus 1. Tapos check nyo kung ano yung magiging ANOVA table niya. Okay? So I've already uploaded this. Tapos i-upload ko na lang yung question para may guide kayo. Pero essentially, ito yung naging result ng experiment. Ito. So actually, ito lang yung kailangan nyo. So this was the result of the experiment. Itong table na to. Tapos from this table, just imagine na kunwari hindi niya nagawa yung 2 to the hindi niya kayang magawa yung 2 to the 3 minus 1. So 2 to the 3 I mean. Kasi ang nagawa lang niya is 2 to the 3 minus 1. So which factor combinations or run combinations should you use for you to do 2 to the 3 minus 1 fractional factorial design? Okay? Tapos try nyo i-evaluate. And just choose one block to choose the block para consistent tayo, same tayo ng sagot all throughout. Just choose the block that has the main factors, no. So in this case, pipiliin natin itong block na to, no. Okay? So in that sense, parang ini-imagine natin as if hindi natin ginawa tong experiment na to. Okay? So parang ginawa lang natin is C is equal to itong mga treatment combinations na to. So if we look at the table, ito, parang as if hindi natin ginawa tong ito. So blank yan. Wala tayong value dyan. Hindi natin ginawa itong BC, AC, tsaka AB. So ang kukunin lang natin is itong A, B, C, tsaka yung ABC. Okay? Okay, malinaw ba yan? So try to do it. Tapos try to compare, no, kung same lang ba yung conclusion na makukuha nyo if you did the full factorial design. So this is the conclusion we got from the full factorial design. So try to look at kung ano yung magiging conclusion if we did a fractional factorial design instead. Okay? Malinaw ba? Questions about the homework? Kaya naman? So it's a 2 to the it's a 2 to the 3 minus 1. It's fairly manageable naman siya, no? Kaya naman siyang gawin. Okay? So, that's for fractional factorial design. Pero I'll be showing you one more, no? Let's do a higher order naman. Let's do 5 minus 2. Or gusto nyo yung i-try natin tong 6. Masyado malaki naman tong 6 pala. 64. Ito na lang. 2 to the 5 minus 2. Let's do 2 to the 5 minus 2. Or 4 minus 1. Original 32. Sige, kaya naman to. 2 to the 5 minus 1. Let's do 2 to the 5 minus 2 para lang makita nyo kung paano yung merong 2 na ano no. I mean 2 defining contrast. Okay? So let's start with copy natin to. So meron tayong 5 factors. So that's A, B, C, D, E, and sorry, 6 na pala to. C. And D is equal to, so ito yung first block natin, D is equal to plus AB. And E is equal to plus AC muna. So this is our first block natin. No? Then we have AB, AC, AD, and AE. Ano pang kulang natin? Medyo marami pala to. Then we have, wait lang ah. Medyo madami pala to. Kaya ba natin ma-reduce? Saglit lang lasa. May check lang ako. Kung okay lang ba na tanggalin natin yung iba. Which I think pwede naman, no? Eh, okay, pwede naman. Gawin pala natin is pwedeng hindi natin isasama to, no? So para ma-reduce natin kasi actually redundant yung iba, no? If you notice, kunwari itong AC, itong AB na to is just the same as this column, no? Tama? So pwede actually natin ma-reduce siya. And actually AC is equal to just the B column as well. Tapos si BC is equal to A column. Para ganyan, based on the aliases. No? So pwede mag-alias muna tayo para i-reduce natin yung number of columns na kailangan natin gawin. No? So ang gagawin natin is we do aliases muna. So our defining contrast here will be, we have two defining contrasts. No? So we have DD is equal to ABD. So this is our first defining contrast. So what I did was multiply ko lang yung D on the left hand and the right hand side of the equation para makuha yung I ko. So this is my first defining contrast, and my second defining contrast is multiply ko by E to. So EE is equal to ACE. So this becomes ACE. Okay, so those are my two defining contrasts. So try natin. A muna. A times ABD gives me equal to sa BD. Sorry. Equal to sa BD. Tapos A times ACE equal siya sa CE. Tama? Then we have we also have B multiplied by ABD. This gives me that's AD. Tama? Then B multiplied by ACE gives me A ABCE. Okay? And last A multiplied by ABD gives me ABCD. Oh, sorry. ABCD. Tama? Tapos, lang last is C times AC gives me, what is this? AE. Okay? So, pwedeng kahit ito lang isama natin, no? Ito mga naka-alias. Okay. Ito na ba lahat? Tinitingnan ko lang class, ha? So, we can do BD, CE, AD, and AE. And lastly, we can do ABCD. Okay? Okay. Ito lang sinama kaya ito lang yung sinama natin sa table of signs kasi pag 'di ba pag nag-table of signs kasi tayo, ah ang mangyayari lang kasi is um ang mangyayari lang kasi dito is isasama lang natin yung merong kumbaga dun sa contrast pag nag-sum product tayo, ite-take into account lang natin yung mga alias na ano no na columns. So hindi natin isasama yung others. So kunwari ito, kunwari nag-contrast tayo ng kunwari may certain values tayo dito, 'di ba? Pag nag-sum product tayo, ipa-plus natin um, pagka naka-negative, pagka naka-positive sign siya tapos ima-minus natin pagka naka-negative sign siya. Okay? So kaya ang lalabas dito is yung A plus BC, siya yung SS na makukuha natin dito. Kasi kasama yung lahat na naka-positive si BC. Okay? If that makes any sense. So kaya although dito kasi kasama lahat, no? Kunwari, A is this column, BC, B is this column, AC, tapos C is equal to AB. Ito. So dito kasi, we have multiple other columns no, na hindi naman kasama sa aliasing. So hindi natin need siya in a way. Tama ba? Hindi, kailangan pala natin yun. Kasi pag nag-minus tayo, kasi ma-minus siya doon pala. Tama, yung minus pala. Okay. Anyway, idadagdag nyo na lang yung ano no, yung mga missing pa na ano dito. Pero sige, idagdag na nga natin. So we have pero in any case, ito yung mga alias natin. So meron tayong alias dito. So kailangan natin delete to no, delete. So we do sige para to be complete tayo no. So we do AB, AC, tapos may 3 pa. AD, and tell me if I'm missing something. AB, AC, AD, AE. Tapos we have A, BC, BD, PE. Tapos last is CD, CE. Kulang pa ba? This is equals combine 5 taken 2 at a time. Dapat meron tayong 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. D. Okay, kulang pa ba? Wala na akong na-miss, no? 10 naman. Okay. Tapos, combine 3 at a time naman. Also gives us 10, which is fairly large. So, hindi ko na i-complete siguro to, no? Pero you can complete it on your own na lang. So, pwede nyo i-extend. Pero ang ipapakita ko na lang sa inyo is how you form the the four groups na necessary, no? Okay? So, ang gagawin lang natin, same sa ginawa natin kanina, which is, actually, ito lang naman kailangan natin, no? So, kahit wala muna to, para mabuo lang natin yung groups, ito lang yung kailangan natin, yung main factors lang. So, pwede ang gawin natin is, so, let's start with -1, -1, alternating to. Tapos, let's copy this. And we are doing 2 to the 5 minus 2, which is um, equal to 4 groups. Tapos yung 5 natin from 64, 2 to the 5 minus 2 is we have 8 runs per group. So meron tayong 4 groups of 8 runs. So dapat ito, 8 runs yung gawin natin. Okay? And let me just do this, no? My next group would be minus, let's do plus AB muna to. And this is arbitrary class, no? So hindi naman kailangan na ano, may specific pattern kayo pipiliin. Pwede naman ganito. So ito, that's my second group. My third group is this, I'll do negative to. Kasi ito naman yung positive. Then meron siya 8 runs. And lastly, let's do negative parehas. Okay, that's my last group. Okay. And similar sa ginawa natin kanina, ang gagawin lang natin is, ito every 2 rows, tapos ito yung next is every 4 rows naman. So let's copy this, tapos 1. Okay. Tapos copyan lang natin to. Okay. Tapos let's do a design generator, no? Etong AB plus minus plus AB siya. So let's just do plus AB. Drag it down. Ito naman plus AC. A times C. Okay. Tapos we do AB equals A times B. So kaya pala hindi ko tinuloy ng class, no, kasi sobrang haba nito kasi meron pa tayong 5. Gagawin natin yung 3-factor interaction. So that's another 10 columns. Tapos gagawin pa natin yung 4-factor interactions. So that's 5 to the 4. Gives us another 5 combinations. Tapos pag dinagdag pa natin yung 5-factor, which is the ABCDE, we have another 1 column pa. So may additional pa tayo na 16 more columns dito sa papunta sa right. So, hindi na natin siya isasama, no? Pero alam ko pwede natin i-trim down. I'll get back to you nito, no? Siguro next meeting. Pero for now, focus lang muna tayo sa paggawa ng groups, no? Hindi muna yung paggawa ng table of signs. Okay, so we do ito, this is positive AC. So, kinopya ko lang to, no? Tama. So, ito naman, kopya natin to. Pero this time, lagyan lang natin ng negative dito. Tama? O, copy natin hanggang dito lang. Okay? So, naka-negative. Dapat negative lang siya nito. Which is, tama naman. Tapos, we do, ito na, copy natin ulit. Pero this time, gagawin natin negative to. Okay? Kasi negative AB siya. Tapos, yung last is, naka-negative parehas. No? So, we can just copy this, negative. Okay? So, that should look right. And now, pwede natin i-ano yung treatment combinations. No? So, what we did earlier is, gawin natin equals, concatenate. Yung first natin na argument is if this value is greater than 0, then we place an A. If not, then we don't place anything. Okay? And we close that in a parenthesis. Tapos copyin lang natin to. So this is C. Magiging C na to. This becomes B. Tapos comma again. Next concatenate natin is this one. This is now D. Tapos ito D2. Tapos ito will become C. And last To this is E. Tapos D naman. A, B, C, D. Tama. And last na, nasa E na tayo. Which is in the F column. So F2. And ito, gagawin natin E. Okay. And we can close that all para i-enclose natin yung concatenate function. Gives us, if we did it correctly, dapat tama to. And we just remove this. No? Okay. Tama ba? Tanggalin to. And ito yung blank natin, which is just the... Yan. So I think nakuha naman lahat, no? Yan. So in this particular case, wala namang ano, no? Wala namang kailangan mo walang specific block na necessary na piliin natin. We can choose any of the blocks, no? So we know that dito tanggalin lang natin 'to, no? So if you were to do the ANOVA, then ito yung mga confounding na or aliases na magiging guide natin, no? So BD here, where is BD? Ay, kulang pa pala to. Kailangan pala natin gawin pa to sa ano, no? Kasi kulang pa siya. Wait lang. Kasi magko-confound kasi to sa dalawa eh. Kasi ang mangyayari dito is A is BD plus CE. B, alam ko na ang kulang natin. Kasi hindi natin ginawa for D and E. So D times, tama. So D times ABD and D times ACE gives us, this is AB, tama? This now becomes D times A equal to sa ACDE, tama? Correct me if I'm wrong, class, if may na-spot kayong mali. Tapos ito, A times ABD. This now becomes ABDE. And lastly, E times ACE gives me AC. Okay, notice how each of the main factor is confounded with a 2-factor interaction, pati a 3-factor interaction. Okay, a 4-factor, I mean. So, nasa na mga 3 factors. Tapos yung mga 2 factors, and let's test it, no? If we do AB times, babalik lang kasi to. Kunwari ABD, this becomes D, which is the same na ginawa natin dito, no? AB is equal to ABD. So, mga kulang is yung mga, 3 factors. So, if we do ABC times ABD gives me ABCD. Sorry. AB, tama ba? CD. So, yun yung kulang ko pala. Wait lang, class, CD. Where is CD? Wala si CD dito, no? Ayun, kulang pa. So, yun. Kailangan pa natin gawin yun, no? Para sa... Tapos, mag-ano pa tayo? ABC. And hindi ko na isusulat yung class, no? Itong times ACE. Kasi sulat na lang. Marami pa to. ACE equal to sa... paano ba to? ACE 1... C matatanggal. BE yung matitira. BE. Okay? Okay ko na nga ito. Tapos, kulang man kasi marami pa tayong pala. Tapos, we have BCD multiplied by ABCBCD. Or ABD muna. Ano, ABD is just the I. Okay yun. CD. Ano, mali yung approach natin. Dapat yung mga two-factor yung ginawa natin para mas madali. So, nandito na ba lahat? AB, AC, AD, AE. Tapos yung next is BC. Wala pang BC, no? So, we can do BC. Mas madali kung ganito ang ginawa natin, no? ABD gives us ABD. Maka-cancel yung B. Gives us ACD. Tama? ACD. Tapos, ito, BC. So, nasa, ano tayo, no? BC, BD, nandito, BE. Walang BE. So, we can do BE. No, sorry. BC multiplied by AC muna. And this gives me ACE. Magiging ABE siya, no? Tama? So, siguro naman you get the point, class, no? Parang kaya nyo nang i-fill out lahat to. It will be maraming multiple aliases to, no? Ang kailangan nyo lang is kunin lahat ng, di ba may one na tayo na mga yung single factors or main effects na solve na natin. Ito siya. Ito yung mga main effects. So nakuha na natin yung mga confounding or yung mga aliases niya. So A is BD and also C. So if I were to write this down, parang magiging ano siya, A plus BD plus CE. Ito yung first. Tapos si B is just equal to B plus AD plus ABCE. Yung C is equal to AE plus ABCD. Okay? So, kumbaga, confounded yung mga effects nila. So, D plus AB plus ACDE. Tapos, last is E plus AC plus ABDE. Ganyan. Tapos, BC plus ACD plus ABE. So, kailangan kasi natin take into account lahat ng combinations, no? Which is, ilan yung na-compute natin? 'Di ba parang actually pwedeng stat problem to, no? So 'di ba meron tayong 5 main effects plus yung 5 taken 2 at a time, which is our two-way interactions, plus combine 5 taken 3 at a time, which is three-way interactions, plus yung four-way interactions naman, plus ano ba last? Yung five-way interaction, which is just one, no? Okay? Tama? 5, 4, 1, 2, 3, 4, 5. Tama. Yan. So we have 31. May 31 dapat tayong i-take into account. Tapos yung, kaya siya hindi 32 kasi yung 1 is yung 1 na remaining dito is yung ganito. Yung naka-low setting lahat. So that's 31 plus 1 which gives us 32. 32 lahat yung treatment combinations. So we need 31. Ang meron na tayo is 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10, 11, 12, 15. May 15 na tayo plus ito 16, 17, 18. May 18 na tayo. 18. So kulang na lang tayo ng konti na lang, no? So medyo madami pa rin. 31 minus 18. Meron pa tayong kulang, no? And if you fill out nyo lang yun, using itong aliasing na ano, no? Using the defining contrast, makukuha natin yung mga aliases na to. So when we now proceed to the parang pag-create ng ano, although, wait lang kasi meron tayong 3 runs. And each of the run, may kulang pa dito. Dapat 4 siya eh. Hindi, okay lang pala. 2. Okay? So pagka nag-ano na kayo, yung pag gagawa tayo ng ANOVA table, magiging ano na siya. A plus BD plus CE. Tapos B plus AD plus ABCE. Although para ano, kasi again, ang assumption dito is yung sparsity of effects principle, pwede nyo siyang i-ano na lang. Nakaganyan siya. So you're looking at factor A confounded with the BD and the C interaction. Tapos ito, factor B, AB, AC. So this is also one way to place it. No? So para ito, in this case, mas malinaw sa atin kung na main factor A, main factor B, main factor C na confounded lang with AE plus AE plus AB, CD. Tapos yung next is D. Papel na lang to. Yan. Ganyan. Kulang pa pala to. Insert. Shift cells down. Source. Tapos meron pa tayo SS. So if you do the ANOVA table, dapat ganito yung itsura niya. No? Ito yung mga sources mo. Tapos sum of squares, DF, MS, etc. etc. Okay? Pero definitely kailangan yung tapusin muna to. No? So you need to do yung BC, BD. Yung iba naka-confound na dito, no? So kunwari, yung BD nandito naman na, so hindi nyo na kailangan ulitin. Kasi yung mangyayari dyan is BD is just equal to A and CE, no? Parang yun kasi yung ano naka-alias sa kanya. So hindi nyo na kailangan ulitin. Okay? Make sense ba yun? So ulitin nyo lang lahat to. So ang kailangan nyo lang is lahat ng mga hindi pa lumabas dito, no? So for example, we stopped at BC. BD is already here. Tapos pagka inano nyo pa BC, BD, BE. BE wala pang BE dito. So pwedeng ang next nyo is BE times ABD. Tapos yung times ACE. Tapos makukuha nyo siya dito. Okay? So it will be monotonous pero masosolve nyo naman siya, no? Lalo na pagka or although in most cases hindi naman lumalabas to sa exam, no, yung mga ganito kadami. Pero usually ang binibigay lang namin at most yung mga 2 to the 3 lang, no. Pero sometimes nagbibigay kami ng 2 to the 4. Pero 2 to the 5 it seems too much, no? Kasi parang ang dami kasing ano 32 treatment combinations kasi siya. So, 'yon. May questions ba before we proceed to Taguchi? Malinaw ba 'tong pag-create ng table? So ang pinaka-importante lang naman itong blocking, no? Because this will dictate kung ano yung treatment combinations na kailangan nyo gawin for particular, lalo na pagka nag-experiment na kayo kunwari. So if you're doing a 5-factor experiment kunwari, 2 to the 5, tapos sabi nyo yung 64 is too much, gusto nyo gawin na 8 experimental runs lang. So pag gumawa kayo ng 8 experimental runs, kailangan nyo mag-fractional factorial. Tapos once you do fractional factorial, you'll end up with something that looks like this. Tapos kung meron na kayong ganito, ang gagawin nyo na lang is pili kayo ng blocks na gusto nyo. So it could be randomized. Wala namang ano, no? Specific block na kailangan piliin. So if I choose this block kunwari, then I run my experiment this way, no? So i-run ko yung DE, then run ko yung A, run ko yung BE, ABD, CD, AC, BC, and ABCDE. Okay? So ito, kumbaga, ito yung factor settings na pipiliin ko so that I can do a 2 to the 2 to the 5 minus 2 experiment. So I can do this. I can choose also this one. It wouldn't really matter, no? Tapos pagka inano ko na, inanova ko na siya, I will end up something that looks like this. No? If you're interested only in the main factors, which is, yun naman yung point ng ano, no? Kaya tayo nag-fractional factorials kasi we feel that the two-way, the higher order interactions ay hindi na necessary. Then, pwede naman, hanggang dito lang kayo, tumigil kayo dito, tapos hindi nyo na isama yung ano. Pero that will reduce the accuracy or kumbaga, anything na hindi nyo sinama dito will come up in the error, no? Kasi ganun yung error. Pagka, kunwari, hindi nyo in-account, kunwari, hindi nyo na in-account si CD, kunwari, ganyan. Ang mangyayari is, yung SS dapat ni CD, mapupunta dito sa error. Parang ganun yung, ano, no? If we only choose to do main effects. Okay? And actually, you can also apply this into the other na ano as well, no? So, yung mga other statistical techniques. So, kunwari, um, yung ANOVA table. Kunwari, yung one way lang yung ginawa nyo, tapos yung two-way interactions, hindi nyo na sinama, ang mangyayari lang, mapupunta lang siya sa error. Uh, which is a bad thing, no? Kasi kung napunta siya sa error, lalaki yung denominator mo dahil yung denominator natin is yung MSE. Tama? So, less likely magkakaroon tayo ng significant result. So, lumalaki uh, yung error ng experiment so as to speak, no? Okay? So, kaya sinasama siya parati. So, dito, kailangan nyo talaga is sama siya, no? Para lumit tong error value na to. Okay? So, I leave it to you para mag-experiment dito. Tapos, i-try nyo i-buuin yung ano, yung table na to. Tapos, try to account for all 32 na or 31 na ano, no, na effects. Yung 5 main effects, 10 two-way effects, another 10 three-way, tapos yung 5 na four-way, tapos yung last na ABCDE. Wala, hindi pa lumalabas si ABCDE dito eh. So it's confounded with either a four-way interaction or a three-way interaction. You'll need to figure it out. Okay? So, yun lang muna for fractional factorial design. We can take a 5-minute break siguro. 5-minute break tayo. Tapos when we resume, mga 10 or let's do a 9-minute break na lang. So, resume tayo 10:05. Okay? So, take a break. Kain muna ng snacks, CR, whatever you feel is necessary. Tapos balik tayo 10:05 to discuss about fractional Taguchi design. Hello? Okay, hopefully nakabalik na kayo lahat, no? So, let's start with Taguchi from this point on. By the way, may nagtanong pala. Kailan po deadline ng homework? I'm thinking 1 week. 1 week from now, so siguro mga May 19. Tapos ilagay ko na lang kasi ano no, parang assignment box dun sa Uble. Okay? So etong Taguchi principle, this is more of an optimization technique, no? Si Taguchi, the Taguchi design. So this was developed by Junichi Taguchi. Nakalimutan ko kung ang alam ko engineer siya eh. Hindi ko lang maalala kung anong engineering siya. Pero he was assigned, or this happened after the World War, no, where Japan was recovering, no, and mostly nag-shift ang Japan into manufacturing, and they wanted a way to parang improve their process, or they wanted to way to make the process more efficient, no, and the best way to improve the process is to reduce variability in the process. So Taguchi based his principle on improving efficiency and decreasing the cost associated with experimentation, no? So usually kasi if you look at kunwari yung mga previous na na-discuss natin yung mga ANOVA, yung 2 to the K design, if you notice na if you do kahit na nag-fractional factorial design kayo, no, or yung full factorial design tapos yung mga two-way ANOVA, etc., it takes a considerable amount of time, no, to do the experimentation. So Taguchi aimed to aim to create a method na parang he wanted the best results in the least amount of time. Parang ganun yung ano niya, no, yung principle niya. And he stated that yung manufacturing planning and activity should be centered on prevention rather than yung mga detecting methods, no. So by taking into account lahat ng factors na pwede maka-affect sa isang process before you actually do the process, mas ma-improve mo yung certain process na yon in the shortest amount of time, no, in the most efficient way. Okay? So, again, sabi niya na if you want to remove the cause of variation, which is sometimes is impossible, no, but most of the time it's very expensive or impractical. So ang goal ng manufacturing is not to completely remove it, pero you just want to dampen yung effect ng certain causes na yun. And this is where Taguchi design comes into play, no. It specifically aimed to parang reduce kung ano yung nakaka-negatively affect sa process nyo without actually removing those factors. Okay? So he wanted to create what calls as a robust na experimental design, or a robust process, I should say, using his orthogonal arrays. So the way it works is instead of doing full factorial experiments, gagawa siya ng experiments according to an orthogonal array, no? And I forgot how we developed this. It's either through empirical methods or meron siyang statistical basis. I'm not quite familiar, no, pero later on I'll show you what these orthogonal arrays look like, no. Pero it's somewhat similar to full factorial experiments pero heavily reduced yung number of experimental runs. Okay? So obviously it from the purist na statistical purist, no, it gained heavy criticism because hindi daw siya improper or incomplete yung method niya. Pero ang argument naman ni Taguchi is would you, and this perhaps ano no, summarizes yung parang spirit of the Taguchi principle. He asks, would you rather have 100 improvement in 5 years, or would you want 60 to 90% improvement in 5 weeks? So, as practical engineers, usually sa manufacturing, usually hindi naman nila aim yung 100%. No? Any improvement is in a short amount of time is better than 100 improvement in a very long time. So, kumbaga ito yung gist ng ano no, Taguchi principle. Gusto niya na some improvement 60 to 90% in just a short amount of time. Okay. So Taguchi's orthogonal array is given as this notation, no? L sub A, B to the C. Okay. So where A here is your number of experiments. Tapos yung B mo is the number of factor levels. Tapos yung C is the number of factors. Okay? So, um, 'di ba yung full factorial ay yung fractional factorial experiment was aimed in reducing a full factorial design, which is good, no? Kasi kunwari if you have 2 to the k minus p, kaya mo ma-reduce either to 1/2, 1/4, 1/8 depending on the ano, no? Pero the problem with 2 to the yung full factorial design is that you can only do two levels, no, or two levels per factor. Tama? Kasi 2 to the k experiment lang siya. And the goal of 2 to the k experiment is not for optimization but rather for screening lang siya, no. Gusto mo lang malaman if a factor is has a significant effect on a response or not. Okay? Ang goal kasi nitong Taguchi design is not for screening pero rather it's for optimization. So when we do optimization, from the first lesson we had, no, sabi natin, if you want to do optimization experiments, usually multiple levels siya and fewer factors. Tama? And opposite naman pag screening experiments, it's fewer levels pero multiple factors. Okay? So that's why etong si Taguchi design is better for optimization because it it can involve multiple levels per factor and it can involve multiple factors pero it is compared to ANOVA na designs, no, it is relatively mas konti kumbaga yung experimental runs na kailangan mo i-provide. Okay? So, ang orthogonal arrays niya will involve the main effects as well as only some of the interactions which will be tested, no? And again, nagbabank din siya sa na sparsity of effects principle, no, na kumbaga yung main effects usually yung um, merong malaking or merong significant effect on the response rather than the higher order na interactions, no? Okay? So, you can search on this online yung mga different na orthogonal arrays and then in fact meron natang parang website that can give you ipo-provide mo lang kung ano yung number of factors na kailangan mo and number of levels per factor tapos magbibigay siya ng available Taguchi orthogonal array for that type of design. And maybe I can show you. Let me search for it now. Let me see if mahanap ko siya class, no? Oh, Taguchi. I think this is the one. Hindi ko mahanap pero this is the closest thing I can find, no? Ito yung closest thing na nahanap ko. Ito din ginagamit ko dati. Pero meron pa yung mas advanced nito, no? Pero this is one of the orthogonal arrays na generators I use. So for example, if I want um, three levels, three factors with two levels each, pwedeng L4 yung design ko. And L4 will look something like this. So parang ganyan siya. Ito yung experiment number, 1, 2, 3, 4. Ito yung column. This is the different levels, 1, 2, 3. Tapos ito yung factor settings for each of those experimental runs. Okay? So if this were done traditionally using ANOVA, then you should have diba, 3 levels per factor. So that's 3 to the 3. Tama? So ang mangyayari is if you want a full ANOVA na design dito, sorry. This is 3 factors with 2 levels each pala. So 3 levels with 2 factors, you should have 8 experimental runs. Pero sa Taguchi Design, it's only 4 experimental runs. No? Okay? Let's look at another one. Kunwari itong 7 factors with 2 levels each. So kung 7 factors, 2 levels, that's 2 to the 7. No? Pero dito, you only have 8 experimental runs. 2 to the 7 is 64, 128 dapat yung total na if you do a full factorial design, no, that's 128. Pero in Taguchi Design, kaya siya na in 8 experimental runs lang. And this is the factor levels that you choose. Oh, so nakaganyan siya. So in ANOVA, pati sa ano no um sa mga yung Taguchi, sa Taguchi tsaka sa ANOVA, usually instead of -1 and +1 yung ginagamit sa table of parang table of signs natin kumbaga, ang ginagamit is yung levels mismo. So for example, ito level 1, level 2, tapos kung may level 3 ka pa, maglalagay ka ng level 3. Pero in um in fractional factorial design and full factorial designs, mas appropriate na -1s and +1s yung gamitin natin kasi when we do table of signs, mas although you can represent it this way, no, kasi wala naman pumipigil sa inyo kasi it's all arbitrary. Ang issue lang is hindi niyo magagamit yung sum product na equation kasi pag doon sa full factorial design, pag nag-sum product tayo, it requires na mag-minus tayo pagka hindi lumabas yung effect, tapos mag-plus tayo pag lumabas yung kung naging positive yung effect. No? So kaya ano mas appropriate doon yung table of signs in terms of -1s and +1s. Pero dito, um, since more than 2 factors tayo, tapos hindi naman tayo magma-minus and plus, usually ang gagawin natin dito is ang gagawin is count if actually, sum if actually yung formula. No? So parang sum if naka-level 1 siya or sum if naka-level 2 siya. Parang ganun. Parang ganun yung gist ng formula. So when we construct the table for factor settings, usually in terms of level 1, level 2, level 3, ganun. 1, 2, and 3. Positive integers yung ginagamit natin. Okay? So I'll show you later what it looks like. Pero this is an example of yung natin. An orthogonal array. And this is, ito yung an orthogonal array for L4, 2 to the 3. Tapos, meron pa bang iba? I can probably show you more, no? I'll show you something na eto. Mas maganda to. This is an L4. This is L4 uh 3 to the 3. Okay? Tama ba? L9 pala, sorry. L9. This is L9 3 to the 4, I mean. So if it's 3 to the 4, dapat if it were a full ANOVA na design, no? 3 to the 4 is equal to ilan yun? 9, 27 times 3. 27 times 3 which is 81 ba? Tama, 81. 81 dapat yung full experiment nito. Pero since we're doing Taguchi Design, ang mangyayari is na-trim down yung experiments natin from 81 naging 9 na lang siya, which is a significant amount. No? That's just 1/9. Tapos ito yung table niya. No? You have a level of 1s, 2s, and 3s. No? So, ganyan. Hindi siya -1 and negative and +1. Okay? In fact, nagamit in one of my research work, no? Ito actually yung ginamit kong run, no? An L9 run. So feel ko pagka kayo gumagawa ng experiment, I would believe you would um, most of the time ito yung gagamitin niyo, no? Ito mga L9, L8 can be used, although pwede rin yung fractional factorial design na lang where pwedeng 2 to the 7 minus 2 na lang gamitin nyo. Pwede ganun. Pero pwede rin to. 7 levels, 2 levels per factor. L8, L9. L12 can be used. Pero itong mga iba, hindi ko sure kung maano nyo. Let's look at L25. L25 is ganito siya. So this is ito yung factors x1, x2, x6. Tapos naka ano siya, no? 5 levels. Okay to kasi This is pagka ano na more than 3 levels na, you can see na umabot siya ng 5 levels. So this is a heavy na optimization run, no? If you have certain factors that can be done in multiple levels, this can be ano no, one of the changes. Although um hindi ako makaisip ngayon ng certain factors that can have 5 levels, no? Kasi if you look at kuwari temperature, usually low, medium, high yung ano natin setting doon. Pero if it's an optimization run, then it might be useful to have ano no, lalo na pagka may certain ano talaga settings that or sensitive yung process nyo doon sa variation in a factor, then it might be appropriate na mag-ano kayo, umabot kayo ng ganito, no, where in each factor can have more than 3 levels, no. Ito 5 levels nga to, L25. This is also a good na design, no. Okay? So, that just shows you kung ano yung mga different na ano no, na orthogonal arrays that are available for Taguchi Design. And it will depend on your experiment kung ano yung appropriate sa doon sa ano yung study na gagawin. Okay? So, let's try this one. We'll be doing L4 2 to the 3. So that's four experimental runs. We have 2 factors for each level, and we have for each 2 levels for each factor, I should say, and we have 3 levels for each. We have 3 factors in total. So we have factors A, B, and C. Factor A has machine speed. Factor B is carbon content, and while factor C is temperature. And machine speed natin, these are the natural factors. Again, I've I don't know. Um, Parang na-state ko na yung difference between natural and coded factors. Later, pag ano tayo RSM, this will be used, no? Itong kung paano natin i-set yung natural factors once we have optimized our runs, no? Pero ito, again, ito yung natural factors, yung actual settings na gagawin natin in the real world, no? Tapos yung coded factors is yung mga -1, 1, or yung 1, 2, 3. Yun yung coded factors. So coded factors are used dun sa statistical analysis na because you can't actually use these natural factors pag nag-analyze kayo ng data, no? Okay? So suppose we did the experiment, no? Sorry. Ang gagamitin pala dito is an L9 3 to the 4, no? Okay. So mukhang dito ang ginawa niya L9. Sorry. Mga examples lang pala 'to. Okay. So, ito yung isang example lang ng ano 'no, L L4 2 to the 3. Ito machine speed, puwedeng 2 levels 2 levels per factor tas 3 factors. Tapos puwede rin if you did 3 levels tapos mayroon kang 4 factors, then you can have L9 3 to the 4. Ito yung pinakita ko sa inyo kanina. Then you can also have L8 2 to the 7, no? And I think pinakita ko rin 'to, no, L8 2 to the 7. Okay? So let's try this. Ito yung example natin. This is an L8 2 to the 7 design. Tapos welding company, gusto daw nila improve yung welding process nila to reduce or prevent broken welds. And na-identify nila na meron nilang 7 factors to be tested to increase the weld strength. Okay? Tapos ang ano nila factors is yung frequency, pressure, alignment, linear amplitude, weld time, joint type, tsaka yung welding direction. Okay? So dito each of the factors has 2 levels, tapos nakasulat dito kung ano yung natural settings for those different factors, no? Again, ito natural settings, and we'll be coding them in terms of ones and twos, no? Okay? So dito may usually pagka yung level 1 should be the low level and level 2 should be the high level. Pero again, it's arbitrary, no? Kunwari, alignment fixture, wala namang ano dito, natural na low level and natural high level. Pwedeng arbitrary lang to. So, aluminum plate yung level 1, epoxy cast yung level 2. Okay? Tapos, ito, joint type, if it's flanged or it's a dovetail, hindi naman arbitrary lang din naman yon. Pati yung welding direction, arbitrary lang din, horizontal and vertical. Okay? Okay. So say for example na meron tayong ganito and these are the results that we've got. Now let's try to evaluate this itong um, results using Taguchi Design. Okay? So ang gagawin natin is, and let me just copy this data, no? Copy natin yung data na to. Ay, sorry. Ay, nasa na yun? This one? Let me copy sa Excel, no? Okay. Tapos, and for this one, wala kasing no, instant na or data tool pack na pwede din gamitin. So, most of, for the lesson today and actually lahat ng mga third long exams, no, um, wala silang quick method, no, or yung one-click method. So, kailangan i-manual nyo talaga. Bakit kulang to ng isang number? Ulitin ko nga. Ah, okay, kaya pala. Nakikita nyo yung screen ko? Kita naman. Okay. Hopefully, nasa Excel ako ngayon. No? Okay. So, ito yung results natin, Excel. So, what we need to do is set up muna tayo ng response table, no? Wherein i i-sum natin lahat ng yung of the same level. Okay? So, what we can do is we can create a response table, no? Call this as a response table. And sa response table natin, dito sa left-hand side, let's just type in the levels. No? So if you have multiple levels, pwedeng may 3 ka pa dito. But since we only have 2 levels for this example, then ang gawin natin is level 1 and level 2 lang. What we do is equals sum if lang. Sum if yung range natin is this one, sum range. Tapos type lang natin, equal siya sa and since gusto ko no, dynamic siya, gawin natin ito. So, tapos yung isa sum range natin is this one. Okay, so parang sinasabi ko, if any of this column is equal to level 1, which is the red cell selected here, I will add all the values that are in this column. Yun yung use ng sum if function. And you can use this sum if also no, sa mga other na aspects in this course, no, pero sum if here is used this way, no. Okay, so we have sum if, again yung range doon sa table natin, yung settings na table natin. Tapos yung criteria natin is this one. We select a certain cell, so if it's equal to this one, then it will add it. And yung this is an optional na no, if hindi nyo specify itong third argument sa sum if, then it will just add kung ano yung nandito. Pero hindi, ayaw natin yon kasi hindi naman natin pinapag-add yung factor settings. Ang pinapag-add natin is the yield, no, or the response, which is itong column na to. So kaya ang sum range natin will be this one. Okay? So ang gusto ko kasi is I should be able to drag this to the right and to the right, tapos gusto ko rin i-drag downwards, no? So if i-fix natin siya, yung itong yung criteria natin should move up and down pero hindi siya mag-move left to right. So ang gagawin natin is i-fix natin yung column, no, which is the letter. So if I put a dollar sign, then it will be sure na hindi siya mag-move left to right pero mag-move up and down siya. Dito sa naman, dito sa yung range column natin, gusto kasi natin mag-move siya left to right, no? Pero ayaw natin mag-move up and down. So ang i-fix natin is ito. Tama? And itong result, we don't want it to move at all. So gagawin natin is i-fix natin both. Okay? So we should get something that looks like this. And if we drag it up, drag it downwards, we should get something. And to check, let's second random number, no? So it's same column, itong D na column, tapos nasa level 2 tayo, which is correct na yung ano natin. Okay? Okay. So pwede na tayong mag-compute ng SS muna, or let's compute SST muna, no? And right now we're only looking at the main muna, no? Hindi muna natin papansinin yung mga interactions. So let's do main, and I'll show you later kung paano yung may interactions naman, no? Okay, which is more complicated, pero we can figure it out. Okay, so let's try to do this. We'll do, ano bang gagawin ko dito? Let's do SS equals, hindi, mali. Let's first do ano muna, no? Yung SST muna, SST. So SST is equal to yung sum square, and again, hindi naman nagbabago tong SST, no? Sum square nitong lahat minus yung correction factor natin, which is just sum, yung ng grand total na to, squared divided by total number of observations, which is count. Ito, no? Okay, so this is our SST. Okay, now let's try to solve for the SS value for the different main factors, no? So ito yung SS ng SSA, SSB, SSC, SSD, E, F, G, etc. Okay, so what we do is sum square nito. Okay, tapos each of the values, tama. Each of the values, ito, sum square, comes from, kunwari itong 346, they come from 4 individual na observations. Tama? So para itong 346 kasi na to, galing siya dito sa itong lahat na naka-level 1. So 79, 91, 84, and 92. Tama? So dapat over 4 siya. Tama? And we subtract the correction factor. Dapat pala hiniwalay ko na yung correction factor, no? Kasi gagamitin ko pala yan. Iwalay ko na. Correction factor ko is the sum of ito squared divided by count nito. Okay? Tapos gawin ko is minus ko na lang ito factor. Kasi gagamitin ko din pala to. Okay? So ito, again, let's do that. Sum square nito, this is variation caused by changing the factor of A, no? Tama? Kasi ito level 1, ito level 2. Tama? Sum square divided by, again, always ang denominator pag nag-compute ng sum of squares, no, is the number of observations kung saan nanggaling tong parang groupings na ginawa natin. Tama? So ito 346 comes from, again, 4 values. Itong 351 also comes from 4 values. No? So over 4 yung gagawin natin. Okay, over 4 minus correction factor. And we have this one. And I want to be able to move this to the right, pero ayaw ko gumalaw tong correction factor. Then therefore, F4 ko lang yung correction factor. Lagay ko ng dollar signs, both column and numbers, no? Or the rows. Okay, so if I press enter and I move it to the right, makukuha ko na yung sum of squares ng main factors natin. Okay? So right now, kasi konti lang yung experiments, usually main factors lang kaya natin matingnan dito, no? Hindi natin matitingnan yung interactions. So ang gagawin natin is we only take the main effects, no? And in fact, hindi tayo interactions pala dito kasi yung ilan nga sa main factors tinatawag natin, ipo-pull natin siya doon sa error, no? So hindi natin siya ma-compute din. Okay? So the way we do this is if we set up our ANOVA table, we do ANOVA. Actually, may method now that I'm thinking about it, class, no? May method pala na kayang i-one click to, pero it requires that you download a software, no? And in most cases, paid kasi yung mga software na yun. One of the medyo sikat na software is yung Minitab. You probably heard of it. And some companies actually, they use Minitab. Yun yung paid na software nila. Unfortunately, wala pa kasi tayong paid license for Minitab sa university. We can avail. I'm not sure if they have a student version. If they have a student version, you can also check it out, no? Tapos try nyo i-experiment siya. Pero for now, pwede tayong gumamit ng Excel lang muna and spreadsheet programs, no? Kasi yun yung madali. Yun yung free, kumbaga. So, we do source, SS, DF, MS, tapos yung last is FCalc, and let's do p-value. Again, I like to do p-value class, no? But if you're more familiar with fcrit, pwede naman fcrit yung gamitin nyo instead of p-value. So we do conclusion. Okay? So source natin, let's do main source A, B, C, C, D, E, F, and G. So notice hindi ko na sinama yung mga interactions, no, kasi for this again usually hindi natin malalaman or masyadong konti yung observations for us to be able to do interactions. Okay? So we have A, B, C, D, E, F, G. And similar to ANOVA, para makapag-interaction ka, kailangan din may replications. No? If you remember yung ANOVA, if we do kunwari two-way ANOVA without replication, wala tayong makukuhang interaction effect. Pero kung may replication, saka tayo magkakaroon ng interaction. Okay? So, we have, pwede natin copyin lang to. No? This is just directly. Pwedeng i-copy natin to. So, the easiest way is to copy. Tapos, paste special. Ito naka-transpose. Transpose. Kailangan pala paste special. Values. Tapos, transpose. Parang ganyan. Para ma-paste nyo siya ganyan. Since naka A, B, C, D, E, F, G naman to. Alphabetical siya. And therefore, alphabetical din siya dito. So, that's the easiest way. Pero kung gusto nyo na dynamic siya, kasi minsan, kunwari, may mali pala dito somewhere, mali pala to. Pag binago to, magbabago lahat ng SS and posibleng hindi mo mabago to kasi nag-paste special ka or nag-paste values ka. So sometimes, ang ginagawa ko is pwede rin ganyan na lang. Equals. Tapos, isa-isahin nyo. Pero, kung madami yung factors, minsan na, prone to error yon. So, what you can do is, you can do the lookup method, no? So, pwede ang gamitin natin dito is HLOOKUP. So HLOOKUP kasi naglo-lookup tayo in a horizontal array, no? So we can do HLOOKUP. Lookup value natin is this one. Tapos hinahanap natin yung ito. Sama natin si first row I mean, kasi ito yung hinahanap natin. So we can do HLOOKUP. Tapos ang gusto natin i-return sa atin is yung 14th na row, no? Kasi this is the first row kung saan niya hanapin si A. Hanapin niya dito tapos i-return niya yung 14th kasi nandun yung SS natin. 14th and what we do is we do exact match. So false yung ilalagay natin. Again, 0 is false, 1 is true. Pwede i-type niyo yung false pero it's easier na 0 na lang. So we can do something like that. Tapos gusto ko i-drag down to. Therefore, fix ko yung table. Usually, kung nag-look up kayo, ang table yung pinifix nyo, no? Yung table array. So, ganyan. So, pwedeng i-drag down natin pababa. And you can see na it automatically fills it out. And dynamic siya na function. No? So, you see 78.125 is kung saan si E. F. So, notice how if I change this F here, magiging yung value ng F siya. So, E. So, if this weren't in alphabetical order, kunwari, for some reason, ang ginawa nyo A, C, B, E, F, D. Parang ganyan. Magbabago din yung So, yun yung kagandahan ng dynamic na referencing class. No? So, I highly urge na if you have the time and the energy, pwedeng i-dynamic reference nyo lahat para at least if something goes wrong, kayang magbago. Hindi nyo kailangan baguhin lahat. No? So, let me return that A, B, C. And notice pag nag-type kayo ng something na hindi niya mahanap dito, nag-error siya. Kasi kumbaga CF, hinahanap niya dito, wala namang CF dito, kaya wala siyang nahanap. So C, D, E, F, G. Okay? So again, meron tayong error, no? Yes, meron tayong total. And ito, in-auto-complete niya. So, cancel lang natin yun. So, total natin, ito, nandito lang yung total. And if we sum this up, sum nito minus, sorry. If we do equals, ito minus sum nito, what happens is, we have an error equal to 0. Okay? Which, ang sinasabi kasi dito is, the total na sources of variation nito is just equal to the total value dito. So, kaya ba natin mag-compute pag ganon kung error is equal to 0? The answer is no, because if you remember, yung MS error natin, yung MS error is the denominator, and if MS is just equal to SS over DF, no? So this is equal to SS over DF, parang ganyan. And ang mangyayari dito is, this will become a 0 value kasi 0 yung numerator, and therefore, yung Fcalc mo, hindi nyo makukompute yung Fcalc kasi you can't divide by 0. Tama? So therefore, eto, ang gagawin natin is we do a technique called pooling, no? So what it does is, when we look at a value, tapos it's a small value, and we pull those value into the error. Kasi 'di ba kung maliit yung SS mo, maliit din yung magiging MS. And if maliit yung MS mo, usually yung Fcalc mo magiging maliit din siya, no? Or nandun siya banda sa region kung saan nag-a-accept H naught pa. Or meaning na nagiging as non-significant factor siya. Okay? So para sinasabi natin na hindi siya significant. Okay? So the rule of pooling is you pool value such that yung degrees of freedom ng error mo is roughly 1/2 of the total degrees of freedom. So if you look at the total degrees of freedom, this is equal to count n minus 1 siya, no? So that's just 7. Minus 1 pa ba? Count minus 1, 7 siya. And degrees of freedom for the source is equal to yung levels minus 1. Tama? And this is 2 levels each. So meaning 1 lang to. And notice na yung degrees of freedom niya, if I drag this to the right, no? 0 din yung degrees of freedom because the number of factors has the same degrees of freedom as the total. So this is exactly the reason why yung error mo is also 0. Kasi kumbaga wala ka naman degrees of freedom sa kanya. Okay? So the way we do this is pili tayo ng smallest values natin, and if we want half of this should be pulled to the factor. So we take 4 values that are relatively small, and those 4 values isasama natin sa error. Okay? So parang gagawin natin is remove natin to the smallest values is eto, no? Ito, tsaka ito. Tama? And these are the 4 values na hindi natin isasama. So what we'll do is, just to show you, ilalagay ko na lang ng ano nga tong control 4 ata. No. Control 3. Control 5. Control 5. So lalagyan ko lang ng strike through para to show na hindi ko siya isasama. Pero hindi ko siya buburahin. Parang ganyan. Tapos ibabaguhin ko lang yung formula ko. Gagawin ko siyang equal sum ng this one, and this one. Okay? And I can move that. So essentially, ang ginawa ko, class, is etong 3 point, if you add this, etong 3.125, ito, and ito. If you look at the sum is 10.5. Tama? If you look at the bottom right, ito yung quick way to know the sum. No? It's 10.5, which is equal to error. Kasi ang ginawa ko nga is pinull ko siya. So yung source of variation from A, C, F, and G, pinull ko na lang papunta sa error. Okay? And yung degrees of freedom nila, mapupunta din sa error. So kaya may 4 degrees of freedom sa error dito. So ito na lang yung tinitingnan ko. So it's valid because since they have a relatively small source of small na sum of square, therefore least likely or less likely sila na magkakaroon ng significant effect. Tama? I hope that makes sense, no? So we have pool, meron na tayong na pool, tapos meron na tayong MS value. So ito, i-ano ko na rin, format painter. Yan na natin to. Ay, sorry. Mali. Ito. Yan. Crash out natin kasi hindi natin siya sinasama. Now we can do is Fcalc tayo. So Fcalc natin is equal to MS over MSE, which is this one. Tapos we fix the MSE sign. And again, buburahin lang natin to. Kasi hindi natin siya sinasama. Okay? Marami pala to. So we're only looking at B, D, and E. So again class, no, kaya natin pwedeng gawin to kasi try to imagine if kunwari itong lowest factor na to is not significant, itong ano no, itong B 6.125 is not significant, then therefore anything lower than it, yung lower than this sum of square is also not significant, no, kasi doon naman nagde-dictate, nagde-dictate naman yung Fcalc doon sa value na yon. Okay, so it makes sense. So magiging issue lang siguro is if for example itong 6.125 is significant, then may chance din na significant tong 3.125, although hindi natin malalaman for sure, no. Pero again, hindi natin kaya siya ma-analyze kasi kailangan talaga natin mag-pool. Okay? So uh, Lawrence asks is lagi po ba na yung lowest 4 yung tinitake into account sa pooling? No, hindi lahat always yung lowest 4 values, no. So it all depends on the total. So for example lang, let's just say na ano class, no, we have ang lumabas dito kunwari lang we have 9 yung ano natin. So for some reason 9 tong total degrees of freedom. So kung 9, roughly ang 9, 1/2 of 9, it should be greater than or equal to 1/2 of the total value. So 9, we should have at least 5 na ano, na degrees of freedom dito. Tama? So kung 5 yung kailangan natin, then we need to pull uh, kailangan natin mag-pull ng ilan yan? 1, 2, 3, 4, 5 values. Nagigets ba 'yon? So kunwari lang 9 to tapos no, sorry. Kung 9 to tapos 1 degrees of freedom each sila, then we just need to, eto 6 yung na-pull natin. So pwedeng ang ginawa natin is nag-pull lang tayo ng 3 values. Kasi pag nag-pull tayo ng 3 values, yung if we add this isa, no, kung wari nagdagdag pa tayo ng isa, magiging 5 siya, which is okay naman. So kaya siya. Pero the problem with this particular problem pala, no, is that equal kasi itong apat na to. So kung magpupull ka ng isa, itong 3.125, kailangan mo rin i-pull itong tatlo, no. So for this case, sakto lang din na apat yung pinull natin, no. Kasi half of 7 is 4. Yes, it should be more than half kung odd number siya. So kunwari 8 to, then 4 is good enough. Pero pag 7, it should be 4. Pag 9, it should be 5. Pag 11, kunwari, it should be 6. And so on and so forth. So it roughly should be more than half, no? Pero it can be more. Kunwari, ang nangyari is, and this is where experience kicks in, no? So kunwari lang class, meron kayong, kunwari, let's just say ganito, no? Ang lumabas na results, mga ganyan. Kunwari lang ganyan. Let's just say ganyan, no? Tapos, tig 1 sila ng degrees of freedom. And I've made it more obvious, no? So, kunwari lang ganito, meron tayong 13 degrees of freedom. Tapos, let's just say an orthogonal design exists na ganito, no? Let's just say na meron tayong ganito, 13. So, half of 13 is around, what is half of 13? Half of 13 is 7. Tama? So, we need 7 values na ipupull natin. So, we can do 1, 2, 3, 4, 5, 6. So, kunwari ganito. So lahat yung smallest value natin is etong mga ones, no? And etong ones na to, if I could highlight them, no? Para ganyan. This makes up 1, 2, 3, 4, 5, 6, 7. Let's just say 2 tong isa, no? Para to illustrate my point pala. So let's just say ganito, no? So I have 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6. Yeah, I have 6 values. So kung ipo-pull ko tong mga 1 na to, so let's just say mga 1.01 na, mga ganyan, no? Kunwari lang mga ganyan. Tapos ito, mga 2 point something. Okay? So, if I were to pull this, kulang yung pull value ko. Kasi ang mangyayari dyan is 6 lang yung magiging degrees of freedom ng error ko. So, ang kailangan kong gawin is I need to pull all this to yung relatively small values din na to. Okay? So, hindi necessary na kailangan 7 lang yung ano ko. Kailangan yung smallest values that I think can have no effect. No? So, for example, ito, equal lang naman sila, 2. So, kung walang effect tong isa, most likely walang effect din yung same value sa kanya. Tama? Did that make sense? And hindi naman pwedeng, kunwari, ito ipupull ko, pero ito, hindi ko siya ipupull. Tama? Parang hindi nagme-make sense yun. Okay? So, in this scenario, ang mangyayari is, actually, ang gagawin ko is, ipupull ko lahat ng ito, plus ito, and ito. So, I have a total of 11. So, mangyayari lang is, yung 11 values na to, tapos dalawa lang i-evaluate ko, itong 24 and 22. So, pwede din yun. Kasi hindi naman, wala namang limit sa number of error, no? Basta yung number of degrees of freedom sa error, no? As long as yung degrees of freedom ng error, hindi siya bababa sa half of the total degrees of freedom. Okay? Uh, hanggang C43 lang. Okay? So, okay lang to. This is fine, no? Na 11 yung degrees of freedom ng error, tapos 13 yung total. Tapos dalawa lang yung tinake into account ko. Pwede yon, hindi yon hindi yon concern. Ang concern lang is yung if yung error natin is small, no? Kunwari, kung sinama natin lahat ng 2, ang magiging degrees of freedom kasi natin dito is only 6, no? Which is smaller than half. So kailangan natin mag-pull pa ng more sources. Okay? So, may isa pang question dito, no? Di po ba maapektuhan yung decision making sa hypothesis if nagpo-pull? Like if accept po talaga si null pero dahil sa pooling ni-reject po. Yes, it does affect, no, lalo na pag fairly close yung values, pero yun kumbaga dahil sa lack of or yun yung medyo flaw ng design, no? Dahil sa lack of degrees of freedom, kailangan talaga natin mag-pull. Oh, there's no way about it, no? So, uh, yun yung kailangan natin i-consider when we're pulling values. But we always pull the smallest values, no, na pasok doon sa ano. So pero kung kunwari ito 5 tong isa, then hindi necessary na ipo-pull natin to. So pwede ang gawin natin is isama natin siya sa ang i-analyze natin is ito. We can do this one, and this one. So kunwari meron pang 3 dito, why not? Isama natin tong 3 na to. So ang kailangan lang naman natin kasi is ma-meet yung degrees of freedom na requirement para sa error, which is anything 7 and up in this particular case, no, kasi 13 to, kailangan lang 7 pataas. So in this case, kung ginawa natin is 1, 2, 3, 4, kinuha natin yung 4 values na to, meron para tayong 9 degrees of freedom. Okay? So again, hindi pwedeng, kasi you might be thinking na, sir, paano pag sinama na lang natin tong dalawang 2 dito, tapos etong isang 2 lang yung ipupull natin doon sa error para saktong 7. So hindi pwede yun kasi since equal sila na value, kumari itong 2, itong 2 na to, 2 na to, and 2 na to, they are of equal value. So whatever decision you make for one case will be applied to the other case. Tama? So hindi nagme-make sense na hindi mo isasama mo yung isang factor pero hindi mo isasama yung other factors which has the same sum of squares. Okay? Dito, dito Kenneth asks if dito sa if example natin, no, we can have 5. Yes, that's okay. So kunwari ang gagawin natin is ipo-pull natin tong 6.125. Pull natin siya pag 5 pero unnecessary siya kasi kumbaga we are not sure if this 6 will not be if this were 3.125, kunwari lang ang nangyari is 3.125 to, no, then we need to pull it dito sa ano sa error, kailangan isama natin siya sa 5. Pero in this particular case kasi 6.125 is we are not sure kung magiging significant ba siya or not, so hindi tayo parang kumbaga willy-nilly lang mag-pull ng values, no? So as ang ano lang natin is we only pull what is necessary. Okay? Ay talaga naka-pull si 6.125. I'm not sure about that. Bakit siya naka-pull? Anyway, I'll double check, no, kung pinull niya yung bakit niya pinull yung 6.125, pero I'm guessing since relatively it's smaller than this one kaya niya pinull, pero for me if I were to do this hindi ko na ipo-pull to, no, kasi hindi siya necessary i-pull, pero let's try to check kung ano yung magiging result. I'm thinking na magiging not significant pa rin tong 6.125 which justifies na ipo-pull yun. Yes, that is correct, Lawrence, no. If you pulled your ano, and by the way it's pulled, no, parang pulled, ipo-pull natin. Parang ganyan. Pull. We are pulling ano, no, yung certain factors into the error. Okay? So, full. Actually marami kayo na nag-PUL. But anyway, in any case, okay lang 'yun. So, we are pulling, no. So ito ipo-pull natin. Let's try to check, no, kung ano, kung etong p value ba nila is magiging significant pa rin siya. Okay, let's do this. Nandito na tayo sa FCALC, so pwede natin i-compute. Saglit lang class before I do this. Okay, so sorry. May emergency lang na tumawag. Okay na class. So let's do the p value, no. So what we do is equals f this rt, and let's check kung nasaan tong value na to. And degrees of freedom is this one, and itong degrees of freedom for the MSE. Okay, so F4 ko lang yan. Okay. Yan. And you can see, not significant din naman siya. So you can see na ito, this is not significant. This is because it's greater than 0.05, and let's just assume 0.05 yung ano natin, no? And this is significant because it's less than 0.05, and this is also significant. And you can see na ano siya, no? Not significant din. So maybe that's the reason that can justify na ano, no, why we can pull 6.125. Pero if it were me, you shouldn't pull more than what is necessary, no. So you only need half. But I'll double check last, no, kung bakit because I'll double check kasi baka yung ginamit niya, hindi, 2/3. Alam ko 1/2 talaga eh. What I know is half and greater, no? So I'll double check why doon sa module natin naka-pull yung 6.125. Pero in any case, whether you pulled 6.125 or not, it will result in not significant pa rin siya. Mangyayari lang is magiging magbabago ba 'to? Let's try to do it, no? What if ang ginawa natin is hindi natin sinama si 6.22. So let's do another case class, no? I'll just copy this all. Yari. Total. Equal natin dito. Okay, so check lang natin kung if we pull 6.125. So let's just say na pinull natin siya. What would happen? This now becomes let's check na to. This is 7. Mangyayari is hindi ko isasama si J21. Tapos di rin isasama si J21. Okay? 5. Okay? Let's check kung nagbago ba. Ay, nakafix pala to. Dito dapat. So, it's almost naging closer siya, no? Kasi since nag-pool nga tayo, lumaki yung error natin. So, kumbaga mas magiging closer siya. Pero ang result pa rin natin is significant pa rin itong si 28.125. So, you can argue na kunwari, what if 0.04 yung ginamit natin na ano sir, na alpha value, then dito it will be significant pero dito it will be not significant, no? Pero yun na yung mga nuances sa paggamit ng method na to class, no? Pero I would suggest na if you were to do this, you don't have to pull si 6.125, no? You only pull what is required of the problem, no? Which is only half. Tama nga ba? Half naman ng 7 is 3.5, di ba? So kailangan 4. Okay? Okay, so I'll send you both of these versions, no, para pwede nyo makita na kung ano yung different ways to solve this. Pero again, I'm suggesting we don't pull 6.125. Okay? So I think we can end with this, no? Unless meron pa tayong ano. Let's check kung meron pa ba tayong okay. Check ko pala class, no, kung may isa tayong example na pwedeng gamitin for the remaining 20 minutes. Okay. Ay, naka-pull din pala siya dito. I'm sorry class. Mukhang ang rule of thumb pala is not it should be greater than ano, no? It's not necessary na greater siya than 1/2. The error should be ano lang pala, somewhere around 1/3 to 1/2 the total. So, okay lang pala na kahit hindi natin doon sa example na binigay ko dito sa baba, kahit hindi natin siya ano, no, pinull yung apat na twos. So okay lang na i-maintain natin 'yun. Okay? Okay, pwede ko naman i-send Martin yung mga PowerPoint slides din. Okay, so anyway, eto So, hindi na nga necessary na i-pull yung 6.125. Although, pwedeng i-pull natin si 3.125 kasi, again, yung sinabi ko kanina, equal kasi sila of value, no? So, ano. So, I'll double check this, no? Yung ano yung requirement talaga for degrees of freedom. Tapos, ilagay ko na lang doon sa announcements natin, no? Kung ano yung required na degrees of freedom to say na sapat na yung sa error natin when it comes to pooling, no? Pero ang alam ko na rule of thumb is around 1/2, no? So if it's around 1/2, okay na yun. But I'm reading one of my sources now and it's saying na it should be roughly around 1/3 to 1/2. So kung 1/3 siya, that's okay. 1/3 to 1/2. So ito, I'm not sure. One thing you can do pala class, no, is uh, para ma-decide nyo kung pwede na bang i-pull yung isang value or not is to compare yung SS niya with the total SS. So for example, ito, if you look at this SS, 6.125 compared to 122, it's relatively small. So kaya that is one way na ginastify niya kung bakit pinul niya si 6.125. Pero para sa akin, itong 3.125, it's very small value, so pwede natin i-pull. Pero 6, maybe it's not small enough, so kaya i-test pa rin natin, which in effect, eventually mapuprove din naman natin na not significant siya through the p-value. So okay lang na isama natin siya. So both methods, kahit sinama man or hindi, not significant pa rin si si factor B, no? Yung 6.125 na to. Okay? So, I have one more example dito and I think we can do this example, no, para but before we do that, kailangan pala natin magdadagdag pa tayo ng isa pang column, no? We have two more columns to add. We have SS prime tsaka yung percent contribution P. Okay? So, itong SS prime, this is what we call as the net. This is the net or the pure sum of squares, no? So, it's computed by this formula, no? So, ang gagawin natin is we take the sum of squares ng factor na yon and we deduct the MS error multiplied by the DOF of that factor. Okay? Tapos yung sum of squares ni error natin will just be equal sa sum of squares total minus the pure sum of squares of the different sources natin, whether it's a factor or it's an interaction. Okay? So in this case, doon sa example natin, dito, ang gagawin natin is to get SS prime, we need the SS value minus its degrees of freedom multiplied by the MS error, which is, ang gagawin natin is, lalagyan natin ng dollar sign para ma-fix siya. So we get that. And meron tayong SS prime dito. So these are our SS prime. The SS prime will be used para ma-compute natin yung tinatawag na percent contribution. No? And percent contribution is computed as the pure sum of squares, yung SS prime mo, that's the pure sum of squares, divided by the total SS. Okay? So in this case, our pure sum of squares is this one divided by the SS. So SS total is this one and we can do a dollar sign para fix natin yan. This is 0.025 or 2%. Tapos we have this one and we can convert this into percentages. Punta lang tayo dito. Gawin natin percentage. So parang sinasabi dito is, let's do something like that. Sinasabi dito is 2.8% of the variation can be attributed to factor B. 20.8% of the variation can be attributed to factor D, and a huge percentage, which is 61.4%, is attributed to factor E. Okay? So, ito yung, bukod dun sa ANOVA, hindi na ito sinasama, di ba? Ito, dito sa, dito sa Taguchi Design, sinasama natin si SS prime and percent %P para masabi natin kung alin yung factors na or we can tell bukod doon sa pagsabi kung significant ba yung isang factor or not, pwede rin natin masabi kung ilan yung percent contribution ng factor na yun. Okay? Okay, and it makes sense na hindi significant to because it only has a very small amount, no? Pero if we were to do dito, kung ginawa natin siyang ganito, then ang mangyayari is we'll end up with something that looks like this, no? Mangyayari is wait lang class ah. Kasi hindi to mag-a-add up to 100%. Tama? 85. Kasi meron, hindi natin nasama yung error. Sorry. Isasama pa natin yung error. Sorry. This is... Okay. Sorry. Equal to sa this one minus yung sum nito. Tama? Ayan. Dapat mag-a-add up na to 100%. Okay. Tama na. 100% na siya. Okay? Kasi kanina 85% lang to eh. Ito, 85%. So yun, tama na. Na 100% na to. So we can say na 2.8% is contributed by B, which is a non-significant factor. Tapos 20% is contributed by factor D. 61% is due to 61% of the variation is due to factor E, and lastly 15% is due to error, no, or parang noise siya kumbaga. Okay, 15%, which is saying na parang um, since we have pooled, no, so parang due to the pooled na rin na ano yun na factors, which is considered as in this experiment as noise only, no, kasi non-significant naman siya. Okay, so if we did it like this, mangyayari is let's check, minus MSC. Okay, kaya kasi hindi ko binago $1 kasi dito. I should make this here. Okay. Tapos yung error natin equals sum, equals in total minus the sum of these two values. That's my pure. If I get I can copy this. Then this should give me my total, which is 1, 2. Okay, tama. So if I add this up, this should be equal to 100%. So in this scenario, not much has changed, no? So itong si factor D is around 20% pa rin. 20.8 kanina, dito 20.2. Dito si 61.4%, naging 60.9% na lang siya, which is close to 60 pa rin. Tapos yung error natin from 15 naging 18.9 kasi etong yung 6.125 yung factor B, pinul na natin sa kanya, no? So it makes sense na tumaas yung percentage na. And wala lang percentage siya dito. 0% kasi hindi naman natin siya sinama na. Okay? So either of this is acceptable, no? If you choose to pull factor B, okay lang. Pero again, for me, you should since enough na yung degrees of freedom, hindi na necessary na i-pull nyo to. So okay lang na isama siya. Okay? So unfortunately, hindi ko alam. Siguro magagawa pa natin yung isa. So let's try the last example, no? Mabilis lang. So this is L9 3 to the 4. This is our last example. And I'll make this as an assignment na rin class, no. So I'll begin doing it tapos I'll leave you to finish up on the ano. I'll just present yung settings, yung response table tapos kayo na magtapos sa kanya, no. Okay? So, let's do this. Let's do the factor settings muna, no. So we have 1 to 9. fill series. Kulang pa lang isa. 9. Tapos we have A, B, C, and D. And we have yung results natin, which is yung results natin has 3 na replicates. And let's just label them as R1, R2, and R3. Tapos ito ay 1, 1, 1, 1, 1, 2, 2, 2, 1, 3, 3, 3, 2, 1, 2, 3. And again, itong design na to class, ito, makikita naman sa L9, 3 to the 4. And this becomes 2, 2, 3, 1. Then we have 2, 3, 1, 2. And inform me class, may mali ako na type. 3, 2, 1, 3. And 3, 3, 2, 1. Okay? Tama ba? 1, 1, 1, 1, 1, 2, 2, 2, 1, 3, 3, 3, 2, 1, 2, 3, 2, 2, 3, 1, 2, 3, 1, 2, 3, 1, 3, 2, 3, 2, 1, 3, 3, 3, 2, 1. Okay? Now, we add the values 27, 31, 28, 16, 18, 20, 19, 14, 21, 23, 20, 25, 25, 24, 26, 19, 18, and 20, 29, 25, and 27, 15, 19, tsaka 18, lastly 16, 17, and 18. Okay, so meron tayong table na. So what we do is, buuin lang natin yung response table, no? So, set natin yung levels. That's 1, 2, and 3. Gawin natin equals sum if yung level na to is equal, or yung settings na to is equal to this level. Tapos, ang sum range natin is dito. Lagay natin dito. And kailangan natin siya ilagay dito kasi kailangan pala natin ng totals muna, no? And total sum. Okay? Yeah. So, balik tayo dito. Gusto natin mag-move left to right. Therefore, yung number yung lalagyan ng $sign. Ito, gusto natin move up and down pero hindi left to right. Therefore, ang letter lalagyan. Tapos ito, ayaw natin mag-move at all. So, F4. Okay? Now we can drag it to the right, drag it to the left, and check. Double check lang. C2. Okay. Seems good. Now, ang gagawin natin is, let's first compute for correction factor. This is just the grand total. So, pwedeng ito lang. Pwedeng ito or pwedeng ito. So, it doesn't matter, no? It should give you the same grand total, whether you choose this or you choose this. So, let's just choose this. Sum squared divided by count. Yung count natin should be kung ilan yung total na natin, observations, which is kasama yung different replicates, no? So then, tapos yung SST natin is equal to sum squared ng individual responses, which is individual replicates, no? So ito, sum squared minus this one. Now to do this yung SS value natin for the different factors A, B, C, and D, gagawin natin is sum square, equals sum square nito. And again, ano yung gagamitin natin denominator? Kung ilang values nang galing tong each subtotal na to, no? Tama? So tingin nyo, for this particular case, ano dapat yung denominator? 3. Some say 3. So it's not 3, no? So that's a good guess, no? 3 siya kasi 'di ba 3 treatment combinations, ito siya 3. 3, pero take note na etong 3 na to comes from also 3 replicates. So it's actually 3 times 3, 9 dapat. Tama? Kasi itong 86 comes from 3 values. Tapos, yung 54 comes from 3 values as well. Tapos, etong tatlong to, which is a subtotal, no? 86, 54, and 54, they come from 9 total values. 3 from here, 3 here, and 3 here. So, kaya kailangan 9 yung denominator natin. Then we deduct the correction factor and we get something like that. And gusto natin move left to right pero ayaw mag-move yung correction factor. Then then we can drag it to the right. And we have something like that. Actually, for this case, no, pwede tayo actually mag-ano dito class, no? Mag-interactions kasi meron naman tayong replicates. Pero for your homework, yung i-complete nyo siya, you can do it the same way na ginawa natin dito. Na main factors lang muna kahit walang interactions. Pero next meeting, I'll show you how you can do interactions dito sa case na to, no? So it involves a different response table, no? Yung response table natin, maglalagay tayo ng something like 1, 1, sorry. There are 4 factors. Yung mga ganyan, 1, 1, 1, 2, 1, 3, and so on and so forth. So later, ipapakita ko sa inyo kung paano mag-work yun exactly, no? Pero right now, kahit main factors lang muna ang gawin nyo. So this is your response table. May SST na kayo, may SS na kayo. Kayo na lang bahala mag-complete, no? Tas SF. Although, hindi ko, pwede naman gamitin nyo yung file na to, pero I would suggest na when you do the homework to, try to do it from scratch. So start kayo with this one, tapos try to do it from scratch. No? Para at least ma-feel nyo kung paano gumawa ng Taguchi Design on your own. Kasi again, most of the lessons dito sa sa course na to, parang namamaster talaga siya through practice. So I would suggest na if you were to complete this, try to start from scratch, no, para tapos i-double check nyo na lang yung answer, no, using this file, no. And I'll be sending this file as well, no, para may reference kayo. Okay? Tapos Martin, Martin has requested na kung pwede i-send yung mga PowerPoint files. So I'll be also sending the PowerPoint files, no, para at least may isa kayong
Sir, good morning.
See, go ahead, Lawrence.
Sir, paano po pwedeng ma-check po yung kunwari po sagot namin sa assignment?
Ulit, Lawrence, sorry.
Ay, paano po pwedeng para ma-check po kung tama po yung sagot namin sa assignment? Papas po ba sa inyo or may parang answer?
Ay, hindi nyo ma-check, no? Wala kasing answer key ako yung bibigay. So, paano ba? Pwede ako magbigay ng answer key after na lang nung na matapos yung yung homework na deadline.
Okay.
So bali may 2 assignments tayo, although magsisend din ako ng announcement para at least may guide kayo kung ano yung sasagutan. Yung first assignment natin is uulitin lang natin yung yung first assignment natin from yung ginawa nating example from before, and I can show it to you again dito. Wait. Bubuksan ko lang ulit, class. That was fractional. Okay. Ito. So, ang first assignment natin, gagawin lang natin ulit to. Oh, hindi nakikita. Ano nakikita nyo ngayon? Ito na nga lang.
Yung PowerPoint user, yun may kita namin.
Ito. Dapat ito yung gagawin natin. So, first assignment is the one we did earlier, no? Yung from 2 weeks ago. Pero instead of doing a full factorial design, ang gagawin lang natin is only a fractional factorial design. So, ito siya. So, ito, this was the one we did earlier, no? Pero we did a full factorial experiment. Tapos, ang gagawin natin is instead of a full, gagawin natin is fractional factorial design. And we will use the groups that have the main effects. So, yung A, B, C, at ABC. So, just look at the, yung mga materials na i-upload ko para ma-guided kayo kung ano yung magiging blocks nito. Okay? So, we do half of this only. So, magiging 2 to the 3 minus 1 siya. We do a 2 to the 3 minus 1 using this data set. Yun yung first assignment. Yung second assignment is, gagamitin natin yung, ito yung second assignment natin. We'll do this exercise. Pero, I've already shown you kung paano siya sinosolve, no? So, eto na siya. So, nakuha na natin response. Tapos, ang bubuuin nyo na lang yung ANOVA table niya. So, kayo na magbahalang mag-pull if necessary. Pero kung hindi necessary, hindi nyo kailangan mag-pull. And lalo na pag ganitong case, we have replicates, which means we have multiple degrees of freedom. Magiging ang degrees of freedom nito is 27 minus 1. So, that's 26. So, I'm based on what kung 26 siya, meaning each factor has 3 levels, so 2 levels per factor. And kung main effects lang, so that's 8 levels, which is more than enough yung magiging error, no? So, you can double check it, pero in this particular case, I think you don't need to pull, no? So just compare the degrees of freedom of the error to the degrees of the freedom of the total. Pero because of the replicates, I'm not sure you need. I'm fairly certain you don't need to pull. You need to pull again. Ang reason lang naman kung bakit tayo mag-pull is if kulang yung degrees of freedom sa error natin. And again, yung sa error, kailangan lang at least 1/3 to 1/2 of the total na error. So absolutely necessary siya dito sa no replication. If you remember itong no replication example natin, it's absolutely necessary because yung degrees of freedom natin sa error dito is actually 0, no? Nung before we pulled, nung hindi tayo nag-pull nito, ang degrees of freedom ng error natin is actually 0 kasi yung degrees of freedom ng total is 7. 7 dito, tapos per factor is also 1. So we have 7 factors, 7. So 7 minus 7 gives us 0. So hindi naman pwedeng 0 yung degrees of freedom ng error kasi hindi tayo makaka-compute, no? Magiging 0 yung MSE, which means actually error yung lalabas sa MSE kasi you can't divide by 0. So yun. Kaya absolutely necessary mag-pull dito. Dito sa case na to, I'm certain na hindi nyo kailangan mag-pull because of the number of replicates. No? You have 3 replicates, which means yung degrees of freedom nyo is 29 times 3 minus 1, which is 26. More than enough yun para magkaroon ka ng degrees of freedom sa error. Okay? So just pero you can when you solve it, you can check for yourselves no kung bakit hindi niya necessary mag-pull. Okay? So 11:30 na. I can answer one few more questions, no? In the exams, given na din po agad kung anong method po gagamitin or yung results lang po. What do you mean by this, Martin? Can you elaborate? Lang pong ibibigay. It depends on the problem, no? Pero in most cases, sasabihin naman ko anong method. Like, what you mean is kung ANOVA ba gagamitin, fractional factorial ba, or ano, no? Or Taguchi. Pag ganon, wherein one method can answer, one problem can be answered by multiple methods, i-specify natin kung anong method. Pero there are some cases wherein, kunwari, find the linear relationship between ganitong factor and ganitong factor. In those cases, hindi namin kailangan ibigay yung method kasi there is only one method to solve that, which is linear regression, parang ganun. So it depends on the problem. If there are multiple ways to solve a problem, then uh, we will specify. Pero if there is only one way, and then we can opt not to specify kung anong specific statistical method. Okay? Other questions before we end the session?
Sir,
Go ahead.
can I ask with regards po sa consultation, pwede pong i-email na lang namin sa inyo yung draft proposal namin before actually passing the proposal.
Pwede
Para
naman.
po, we can hear your feedback rin po.
Okay,
Kung
that's good din. Pwede bang, again, I encourage na gamitin niyo tong link na to kasi, again, nalilito kasi ako pagka, ano, no? Pumapasok, ay sorry, kay Martin ko na-send. Ipakigamit na lang tong link na to kasi,
yung answer stancer,
oo, slash pala yan, bit.ly/stat. Oo, kasi minsan, pag pumapasok siya sa email ko, lalo na ngayon kasi naka-remote learning tayo, tsaka naka-online lahat. Lahat ng galing sa university, galing sa admin, pumapasok sa email ko, no, napa-flood yung email ko, hindi ko na susundan yung parang if ever may nagpapa-consult. No? So I suggest na gumamit kayo nito kasi doon mas nakikip track ko through the consultation thread.
thank you, sir.
Okay, sige. Wala na? Can we end the session now? Can I have a thumbs up or yes button kung okay na tayo sa lesson for today?
Thank
Okay,
you,
man.
sir.
I think okay
Alright.
naman.
Okay, thank you for the feedback, guys. So thank you for coming today. I hope you had a wonderful rest, no? I hope na recharge kayo and ready for the second half of our course, no? So thank you for coming in today, and I'll see you next week, and hopefully you have a wonderful lunch. Bye, everyone.
Yes, sir.
Thank you po.
Okay. See you.